Today's hackathon, we are going to revise the module 7. So for the people who have recently joined, I'm just going to point you out in the direction of how to start on this particular hackathon. So do not worry if you are joining for the first time, right? So I'm just going to show you where you can find the current module that we are revising. Okay, let me go ahead and share my screen. Okay. Now, if you visit your Teachable account, in the Teachable account, you can see that there are all the modules listed. If you started recently, if you joined recently, you can begin from the start, right? So you can definitely go ahead and begin from here, the module 1 and 2, the orientation and everything. So we have completed in our revision from module 1, 2, 3, and we are now currently entering the module 7. So basically, if at all you have missed and you are, parachuting into the current module or revision hackathon. Okay, am I audible? So if I'm audible, type A in the chat box. So Vasu says not here. Thank you so much, ma'am. Yeah, so let me tell Vasu sir, connect to audio. Okay, thank you so much. So now, if at all you joined recently, do not worry. We are going to complete till 10 modules, then cover little solidity and start from the beginning. We are going to begin revising from module 1, right? So do not worry if you have missed anything. You can start coming from the first lecture itself, taken by the primary faculty here, Professor Pandurangan sir. Okay, so today we are going to cover the module 7, which is blocks and introduction to nonce, the one element that was there in the blockchain header, the blocks header. So we are going to discuss that. So I'm going to quickly revise what we have done in our previous session. All right. So I'm just going to say hackathon 6. Okay, so in our previous hackathon, we have seen that whenever there's a new block that is getting created, there is something called header, and this header is of 80 bytes. And these are all the elements that are included in that particular header, right? So in previous session, we have understood what is Merkle root, where the Merkle root is going to be the transactions hash. For example, within each of the block, let's say if this is the block, there'll be a block header, and in that there are series of transactions. So let's say if you're looking at our a 5 lakh block or other blocks, they were roughly 2,700 transactions, and all of them will be listed in the body, right? So now what was Merkle root? Merkle root was all these transactions starting from 1 till n. All of them will be concatenating, all of them will be hashed first. So for example, there are n transactions, let's say 2,700 transactions, there'll be 2,700 hashes, and 2 hashes will be concatenated together and hashed again. So this continues till end, till you reach half sets of n. So you're going to concatenate both, and then again you do the process until you reach the top element, right? So that element becomes the Merkle root, right? So this value is also going to be stored in the block header. So what is the reason of having it hashed in this particular format is because, for example, if there is any small change that happens in any transaction, let's say if transaction 3 was tampered or changed, the hash of that particular transaction will change, and the combined hash will change, and the Merkle root will not match what the one that is mentioned in the block header. So when there is a mismatch found, it will be flagged as manipulated or tampered, and that block will not be accepted. So this is what we have understood in our previous session, and today we'll understand this one element which is called nonce, and as we proceed forward in our upcoming sessions, we'll also understand more about proof of work and the consensus protocol, right? So now I'm going to start on this particular session. If at all you have already gone through the module 7, you'll have the understanding of it. We are going to revise it. If at all you are joining for the first time just today, you can stay and briefly understand it, or you can begin from the start, right? It should not be a problem. Okay, so let's begin. I'm going to share my screen here, right? So in module 7, Professor Pandurangan sir revises a few concepts that we have previously discussed, like what a block consists of. The block will consist of the block size, the block header, which will be 80 bytes, and the transaction counts, like the number of transactions. Let's just say there were 2,700 some change transaction, including the Coinbase transactions. So we'll understand what is the Coinbase transaction as we proceed forward. It is the first transaction in the block. So we are going to understand more about it as we proceed forward. And then in the block, there are rest of the other transactions. Like let's say in 5 lakh, the block, we have roughly 2,700 plus transactions. So this is what are contents of the block. And now if you want to understand what are the contents of a block header. So first was the version header, one version number that we have seen previously, and hash of the previous block's header, right? So whatever 80 bytes of the previous block is there, the hash of that will be also saved in the new content, the new block that got created. The reason for that is, see, all of these blocks that are getting validated and confirmed are connected to the previous block by the hash pointer. So what is the hash pointer? Hash pointer is nothing but this previous block headers hash, right? So whenever a new block is getting created, it is also saving a link to the previous block, which is also in another way called chain. So every block is connected to the previous block by saving. There's no physical connection between any blocks, but that value saved in the header says that this is the next block to this particular header. So that is also named as chain, and that is how the whole blockchain is formed. So we have understood the Merkle root in our previous session. Then the timestamp meaning there are two ways, like the time at which the miner begins the mining, I mean starting the validation or of the block, or the time at which he ends the mining process or validation process. So here when we say timestamp that is there in the block header, it is time at which the block is begun, right? So the mining has begun. So time at which the miner begins the validation process. So that is going to be the timestamp, right? Okay. So now the difficulty target. Okay. So we are going to understand more about difficulty target in our upcoming session. A little about it will be covered in today's session, but I will understand more of it as we proceed forward. Today, we'll also understand what is nonce. So there is also one element of the block header, which is called nonce. So every element has its own size. So when you sum all of it together, it will be 80 bytes, right? So the nonce is 4 bytes. So it's going to be a 4 bytes number. I mean, the alphanumeric number, it could be a numerical, it will be a numerical, which will be saved onto the block header. So let's try to understand why we need a nonce in the first place, right? So now what happens is whenever a block is being created, right? So how do we know that the whole network, so all the nodes in the network, how are all of the network nodes staying in sync? Meaning, for example, there is some change happened. So how everybody is also sure that that is the same change that happened, because it is not centrally managed. What happens if you are a bank account holder, let's say, and the example taken by professor here, is, let's say if you are in a Canara Bank account holder, if you have withdrawn say 5,000 today, your central value in the bank's database gets updated. So you can go and do transactions from elsewhere also. The update has been done on the central. But now when there are like say so many nodes, let's say for an example, there are like 8,000 nodes or something. Nobody knows how many nodes are currently active when a person is joining as a node, when he is leaving, when and how many are there currently active, right? So none of that information is available. So how all of these nodes are staying in sync, right? So that is one thing that we need to understand. So now we also need to understand that. Then we also need to understand who gets the authority to generate a block, right? So whenever a lot of transactions are being created, when say person A is sending to person B, a lot of transactions similarly are getting created. And these are in the memory pool first. And when they are in the memory pool, a few of them are getting validated and added onto a block, right? So now many miners are trying to do this, right? So there are set systems which are trying to do this, but how will we know that who is the winner? How do we say that this particular miner has won and he has the authority to generate this block and get the transaction fee pertaining to that block, right? So because there are multiple people trying, so there has to be some system, right? So there has to be some agreement that everybody agrees, okay, now because of this particular person has become eligible by doing so and so task, which is commonly agreed upon in the whole of the network, then only he has the authority to generate a block. So now that agreement is also, the actual definition of the consensus is the general agreement. So if you go and search for the definition of consensus, it is the agreement only. So there has to be an agreement. So there has to be a common consensus that must evolve among all the nodes, and then only everybody is going to say, okay, because that person, according to the consensus, he was the first person to do so and so thing. For that reason, he's going to be the winner and he gets the authority to generate a block, right? So that is what is the consensus. By consensus, we mean the agreement. There are a lot of things that come under that. We're going to cover all of it in our upcoming sessions. So in this short session, we are going to understand more about that one particular thing called nonce, right? So now who gets to decide who is the winner while mining for a block, right? That is what we have discussed. So now before getting there, we'll try to understand what are accepted, expected attempts for an event to occur, a little probability. For example, even professor explains in the session, let's say if you are tossing a coin, so the probability of it is going to be 1/2 of it being heads or tails, right? So let's first go ahead and do that. So if it's a toss that is happening, the probability of it being heads or tails is 1/2. If you are rolling a die, the probability of it being one number is going to be 1/6, right? So now to understand how to ensure every node does some amount of work, some computation, like we only give the authority to that node which has done the computation, because mining in blockchain is a computation heavy activity. So how do we ensure that he has done some work and then only he is eligible to win that reward? So there has to be some proof of work that the person is putting, and we know that, okay, that there has some work, the work happened, and after the work happened, he also became eligible by a common agreement, right? So there was some proof of work that he did some amount of computation, and there was also a common agreement that based upon the common agreement, he was able to go ahead and generate or mine it, right? So then only we know that he is the winner. So if the probability, why we are taking these examples of toss and rolling a die is trying to understand how many expected attempts would be required. For example, if somebody says, an example taken by professor in the session is, if there are, if you want to roll one from a die, right? On a you have a die in your hand, and say to move ahead in the game, you have to first roll a one. So the first person who rolls a one first goes forward, and after that, how much ever number comes, he goes ahead. So to roll one, so how many attempts? So this is a question that even professor asked during the session. So how many attempts do you think it would take for the person to roll a one? Right. So can anyone try to take a guess of how many attempts that a person might have to do to get a one on the dice? Yeah, so you can put it on the chat box. Like if any guess you're making, you can just go ahead and put it on the chat box. Okay, so Jumam says 6. Kumar Raja sir says n number of, right? Okay, so both the answers are correct, but the context is different, right? So what Kumar Raja sir said is the answer to this question, which is how many number of attempts are required to roll a one, right? We are not sure. It could be any number of attempts, right? So it could be, he could roll a one in the first attempt. He could roll a one in the 100th attempt also. Like it's a very rare probability. He might be able to do it in lesser attempts, but the rare case, and he's not able to do that, there could be a probability that he would be able to do it in the 101st attempt also. So Kumar Raja sir, the n number of attempts is correct. And so, but we'll not be to do an approximation, we'll not be able to work with our unknown number. So that is the reason we say, instead of saying attempts for an event to occur, we say expected attempts for an event to occur. So that is where the number 6, Sujamam, that you have said, comes in, where we say there could be at least 6 attempts. We are just making an assumption, it could not happen, but the expected number of attempts that can be made to get that one is 6, right? So there is also a small formula for that. So I hope this particular thing is clear. The difference between the attempts for an event to occur and the expected attempts for an event to occur. So if this is clear, type C in the chat box. Thank you, ma'am. Great. Thank you, Kumar sir. So now how many attempts you have to, thank you, Sharai. Right. So now the expected number would be 1 by P. So now the probability is 1 by 6. And the expected number of attempts would be 6. Right. So in a general scenario, if at all we have to say how many attempts it would take n number of attempts. But the expected number of attempts for us to do an approximation, we do 1 by P, the probability of that event to occur, and we'll get to an expected attempt. Now we'll also try doing for another example, and then we'll see how hash function, because hash function also generates random numbers, and it generates from a range from 0 to 1 particular number. So we'll also see the probability there, right? Now we are still understanding. So now probability is number of favorable cases by total number of cases, right? So when we say the expected attempts to be made for rolling one number, so when we are saying one number, it was the number of favorable cases. How many we needed was one number out of 6. So that probability became 1 by 6. So let's say there is a class of 30 boys and 2 girls. And for us to, and there is a random, list chits are there and you have to pick. And for it to be a girl's name, the number of favorable cases here is 2. The chances that it would be a girl's name, the favorable cases is 2, and the total number of cases is 32 and is 1 by 60, right? So that is how we do the probability here. And the expected attempts for an event to occur is 1 by 16 is 16 attempts. So this is what we are concerned about. So let's say at least a person has to make 16 attempts, and there is a chance that one of them will be the name of a girl, right? So in this particular example, right? So now coming to nonce, so a few things. So for in the same case, when you are trying to do a hash, when you're doing a hash function, it is going to be a binary number, let's say a number which is which has zeros and 1, and it is 256 bits, right? So it is going to be 0 1. We are talking in binary here. So in hexa notation it will be different, but we are talking in binary. So it is going to be 0 and 1 and 256, right? So there are the total number of values that can be created. Like, so for example, if you have hashed any particular value, any particular input, right? So the chance of the output of the hash will be from 0. So how many values could be made out of it is from 0 till 2 to the power of 256 minus 1. So this minus 1 is because we are starting from 0, not from 1, right? So the total number of hash values that could be generated is, the whole range is from 0 to 2 to the power of 256. And so the probability of hash value, so now this is what we are doing is here in our previous case. Let's say if when we said the probability of the name being a girl's name was a case, like instead of that, if you say if there were 32 people in the whole class, and we're not mentioning gender as like 30 boys or 2 girls, we say 2 members, like said there are 2 names, right? So what are the chances of the name being out of these 2 people, so which is less than 2, right? So out of these 2 people is also going to be 1 by 16. So similarly, the chance of being the name being out of less than 5 people is going to be 5 by 32, right? So similarly, we are also going to assume in our probability of hash a number like this, like 2 or 5. We are going to say it is going to be called t. T being the threshold. Here what we are saying is the threshold is 2. Out of 2, out of all of these, we need it to be less than 2, right? So we are going to call that particular number as t. The probability of the hash value being less than a value t is t by 2 power 256, right? So if we compare to our previous example, 2 by the total number of cases, right? The total number of cases here is 2 power 256, and it being less than a value is going to be, the threshold is, let it be t, right? So we are not aware of what is the threshold yet. So we are going to, instead of considering it 1 or 2 or 100 or any number, we are going to say it is going to be t, right? So if it is clear till now, right, the threshold t is going to be a number, a random number that is going to be our threshold out of all the 2 power 256 values that are there in the set. So if this is clear, type C in the chat box. So you have to just try to compare it with our previous example, and T is going to be that threshold. Right? Thank you, Sujaman. Okay, so we are not right now trying to know what is going to be the threshold value. We are going to come to that threshold, right? So now let's just say T is going to be the number of attempts. Like I'm just giving you an example. So we are going to set it, right? So it is already set in the consensus protocol, right? So protocol, everything goes as per that system only, right? Yes, thank you, Shiraya. So let's say it's going to be a number. We are not going to set it or give it a value right now, because that is where we are going to set the difficulty. The probability could be lesser or higher based upon the value of t, right? So you're not going to set that now. Now, to understand what is this value, the nonce, right? So what? Thank you, Ravindra. So now, whenever there is a hash happening, right? So for example, there are so and so many transactions in the block, right? And a miner, what he is doing is he is trying to hash, because he is going to do the computation. So what is going to do? He is trying to do the hash of all the transactions, right? So when he is doing the hash of the whole set, every time he is doing an attempt, he's going to number that attempt, right? So let's say first time he's did, he hashed, when he's trying to do the hash or starting the computation, he's going to first hash it and, say it's starting from 0. So he's going to concatenate it with 0. And let's say the t value is going to be the deciding factor. Like if it is going to be less than that t value, then he's going to be a winner, right? So this t value is something that we are going to discuss about. But what is this number? So the attempt that he is making is going to be called as nonce, right? So now to put all together, when a person is making a lot of attempts, he's going to number each of the attempt here, right? And there will be one particular attempt. There will be one at one particular attempt. What is going to happen is his value will be less than the threshold value, right? And that particular number, that is when we will know that this person is the winner and he gets the authority to create the block, right? So we'll try to understand this, a little bit more with the example, right? So now I'm just reiterating what is the nonce is he's going to label all the attempts, and if whenever he's going to do the hash, if that particular number is going to be the whole hash value, it's not the nonce value. The nonce is not going to be less than t. The hash of that particular transactions concatenated with that number, the attempt, the nonce that he did, if it is less than the threshold that is set, let's say here we said five girls or 5 people, right? Similarly, there is a threshold that is being set. If that number, the whole hash value is less than that threshold, and then that particular number is going to be called nonce. And the first person to achieve that is going to be the winner. And then if you become the winner, you become eligible to construct the block, receive block rewards, and sum of all the transaction fees, right? So we'll try to first understand if this is clear, like if this portion was clear, right? So what here is happening is there is hashing happening of the whole message, and every time the attempt is being recorded, and there is one attempt, because the threshold is, there is one threshold t, and the hash value at one particular attempt will be less than that threshold, and the first person to do that is going to be the winner, right? So if this is briefly clear, type C in the chat box. Okay, thank you, Ravindra sir. Thank you, Suju ma'am. Okay, so now, so we'll try to understand this. Now, what is happening here is this particular number. I'm also going to share a reference. I will also go through that, definition written there. So now, because we have also understood, so now from 0 till what attempt that person can go is also something that we know. So there's from 0 to till which number. So what is the max attempt? The max attempts that a person can make is, because this number is going to be 4 byte, which mean it is going to be 32 bits. So it's going to be 2 to the power of 32 minus 1, because it's starting from 0, right? So there could be how many values altogether, right? That could be created as 410 crores, right? So, that value was summarized and put by Professor Pandurangan sir for ease. It would be approximately 410 crore, right? So it can start from 0 and go till 410 crore, right? So that many attempts could be made. And let's just say one of the attempts that a miner is made, let's say it's a random number. Let's say he made 79th crore 85 lakh 61,271 attempt. At that moment, if his hash value was less than the set threshold, he is considered to be the winner, right? So why this value is bigger is also because we do not want the computation to be so easy that the winner is there's a lesser range for people to participate, right? So that is the reason the number is also huge, and there is a lot of computation. So now you can imagine how many attempts a person has to make, the system has to make to actually set have the hash value less than threshold, right? So out of 410 crore values, if this can go in a sequential manner and this can go in a random manner, right? So there is one number that is going to make that particular person winner, right? So that is what is going to declare him as a winner, right? So now let us try to understand more about it, right? So there is a set difficulty that is intentionally being included in that particular system. So I'm just going to share a reference here. So this is the reference. So I'm going to share it with everyone here on the chat. Okay. Yeah. So now, if you look at, we'll just go through nonce. Now, a nonce refers to a number or a value that can be used once. So number that can be used once is nonce, right? N ones, right? So the nonces are often used on authentication protocols and cryptographic hash functions. So that is one thing that is also being used by our consensus protocol or our protocols on the Bitcoin. In the context of blockchain technology, a nonce refers to a pseudo random number. So it's going to be random, that is utilized as a counter during the process of mining. So it is, the attempts or count of that attempt that we have discussed. So a nonce refers to a pseudo random number that is utilized as a counter during the process of mining. For instance, Bitcoin miners need to try and guess a valid nonce, right? As they perform multiple attempts to calculate a block hash or the hash of the message that in our case, in our example that meets certain requirements. So what are our requirements? It should be less than the set threshold value. So that starts with a certain number of zeros, right? So we're also going to understand that. When competing to mine a new block, it's when somebody is trying to compete to mine a new block, the first miner to find a nonce that results in a valid block hash. Valid in our case is less than being the threshold, right? So there could be from 0 to 2 to the power of 256 values. If it is less than our set threshold, then the person is a winner. And that particular person is granted the right to add the next block into the blockchain and is rewarded for doing so. The block reward is given, and also sum of all the transaction fees is also given, right? So I hope this concept is clear. You can also continue reading on each of these extensions. So now We'll also come across our proof of concept in our upcoming session. But today we are going to dedicate more on the threshold and the nonce. Right. So this particular article will give you clarity on whole of our today's session. So let's go ahead and understand. Right. So now let me just check if the understanding of nonce is clear. If the concept of nonce is clear, type C in the chat box. Not just briefly, it is super clear. If it is clear, you can type C in the chat box. Yes, thank you, Sharai. Thank you, Ravindra sir. Okay. Right. Now let's come to that threshold. We are going to discuss threshold as we proceed forward also, but today we'll try to briefly understand threshold. Right. So now T can be called as threshold. Now the hash of M concatenated with nonce should be less than T. You should have got a nonce such that M is the transactions validated onto the block. So M is going to be the whole of the transactions to be validated onto that block, including the Coinbase transaction. Sorry. So when we say M, what is M? It is the transactions that are to be validated onto the block, including the Coinbase, meaning the initial transaction. So now Coinbase transaction does not have the input from the previous block, right? Normally whenever a normal transaction happens, there are inputs and outputs. But for Coinbase transaction, the first transaction on that particular block will not have inputs, right? And that is where the miner has some scope for adding his own inputs, right? So if you remember the Genesis block, the miner, the first person, there were a lot of default values that were created while Genesis was happening, but you can also take the leverage to add your own message there, right? So that is where one message was added that was connected to the 2008 crisis. Now here, what miners use this Coinbase transaction, that particular value, what they add there is because there are 2x256. Like I'm just going to take back. Let me just go back here. Okay, so it's all here. So because there are going to be 2x256 total values that could be hashed, like the hash could be from 0 till 2x256, but the nonce is always going to be 2x32 only. The max value is 2x32, meaning there are chances, like because 2x32, there is a full chance that a person will run out of all the 410 crore attempts, meaning 2x32 attempts, he is exhausted, and he still might not be able to find, validate, like, comply to that particular condition, which is the threshold. The whole hash could be less than threshold, right? So how many of you are understanding this concept? Like his 2x32, there are chances that it might not be in that 2x256, and he might have to start from where he left. He might have exhausted all 2x32, and he has to start his nonce from 2x32 plus 1. From there again go till another 2x32. So because the nonce is only 4 bytes, so he'll only be able to experiment with 2x32 items only, right? Values only, right? So what people do, miners do, is it's like a counter. For example, if you have 108 counter or 100 counter, what do you do? Once you finish whole of the counter, you write somewhere, right? So one whole cycle is done, you write it, and then you start from second cycle, right? So once you finish the second cycle, then you write 2. You do not have a bigger cycle. So for example, if you're doing that, beats thing, right? What you do for every cycle you do, you write 1, 2, 3, you count the cycles. So there, what people do is they use this Coinbase miners. They'll use this Coinbase to note that he has exhausted 1 cycle of it, 2 cycle of it. So they'll have their own value. So how many of you understood that there is a possibility that the person might be able to, he might be exhausting all of his 2 power 32 transactions and still not be able to, validate to the condition that his hash being less than t. So how many of you understood that? If you understood that, type U in the chat box. Thank you, Sujima. Thank you, Kumar sir. So after doing 4 power 10 crore attempts also, there is a chance that the node will not be able to comply to our condition. So that then they'll note the counter in the Coinbase transaction, because there's no input there. He can have that, use that space, and he'll not be able to edit all the other things like output value, all of this. Yeah, so Ravindra says, meaning exhausting all the cycles or one of the few cycles. So if he's exhausting all the cycles, the probability that he'll be less than t is already achieved somewhere. But there is one chance that, like, the few chances that he'll not be able to do it in one of the cycle, right? So thank you so much, sir. Right, so that tough is mining, right? So mining, the node has to hash every time and count the nonce, and there is a very small probability that he becomes the winner, right? So the probability is intentionally made very small that a person becomes a winner, so that more people attempt the mining and there is more validation happening, right? So that is it. So we've understood this particular thing. So now now the M here is going to be all transaction, including the Coinbase transaction, right? So now the thing that we were discussing is here in the Coinbase transaction, the miner has got 100 bytes to save his own message. So he normally, the miner uses it to say that, okay, I have, so and so many cycles are done, so that he can start from, that will be a counter of the counter, right? So he's actually, nonce is the counter, but if he's not able to do it in one cycle, he's counting that count in that, a Coinbase transaction where he has got 100 bytes. And once he exhausts everything, he starts from there again, right? So this is what it is. And this is what we have discussed again, right? Instead of H, SHA-256, message along with the attempt that is being made. And this is going to be called as nonce wherever it is the hash value, the SHA-256 value is less than t. That is going to be the nonce. Okay, so now the value of threshold, right? So now, for example, the hash value could be from, let's say, 1, and it can go to the 2 power 256 values, and the threshold, like, for example, if let's considering the 32 people in the classroom example, and 2 was the threshold, and 2 power, like, let's say 32 people is the max favorable cases, right? So now any value starting from 1 till the threshold is going to be considered, right? So if the hash is going to be between this for any number of nonce, like any number of that particular attempt, and that random attempt is going to be considered as a winner. So if he falls in this category, he's going to be considered as a winner. So to make the probability smaller, what while making the consensus protocol, it has been decided that the t value could be 2 to the power of 224, right? So meaning how many attempts that could be made here is 2 to the power of, like, if you remember, 2 power 32, 2 by 32 we were doing. So if the value of threshold is 2 to the power of 224, what is going to happen? The total number of attempts that needs to be made is 2 power 32 attempts, right? So there will be every, like, for example, one attempt that made and he was not able to get out of that 410 crore transactions, he can go ahead and do 2 power 32 attempts and continue doing that. So the value of threshold for that reason has been set to 2 power 224. It's a value currently, like, it's not like a variable value, so you can remember it. So the value of the threshold is set to 2 power 224. What this does is it gives a lesser probability for a miner to actually go ahead and mine, right? So many people participate, and by many people participating into that competition, what happens is for yeah. So the logic that Professor Pandurangan sir explains, Ravindra sir asked, is there any logic for choosing 224? So what Professor Pandurangan sir explains is the threshold being set for 2 par 224 gives the total number of attempts that a person can make. That attempts will become 2 par 32. So the number of cycles he can make will become 2 par 32. And the probability will become for a person to be able to get it comply to the condition is 1 by 2 par 32, which is a very small probability, right? So that is the reason. So the actual reason was to make it difficult for the miners to mine, right? So that is what is there. And that is also called this 2 par 32 because it is in difficulty of 2 par 32. So this 2 par 32 is also known as 1 unit of difficulty, right? So this 2 par 32 hash, trying to evaluate between this 2 par 32 hashes, is also known as 1 unit of difficulty. So we are going to discuss more about the unit of difficulty in our upcoming session. But in this session, we wanted to understand what is nonce and how it will help us in trying to understand who is the winner and how difficult the whole competition is. So in this session, we wanted to understand what is nonce and the difficulty that is involved in trying to mine, right? So this is the whole of this. So which brings us to the conclusion of today's session, which is half the module 7, right? So we'll also understand more about the difficulty, unit of difficulty. The value of threshold is 2 par 224, which helps us make the probability of miner winning smaller. And this 2 par of 32 attempts that a miner can make, the number of cycles that he can make to win, right? So that is the reason it is called 2 par 32 is called 1 unit of difficulty, right? So I'm just going to share, go through the reference once again. So now if you see, let's say I'm just going to read about difficulty. Yeah, so in other words, the process of mining consists of miners performing a myriad of hash functions, right? So many of hash functions with many different nonce values until a valid output is produced. If the okay, so let me say I said difficulty. Yeah, where are we? Yeah, so the miners employ a trial and error approach. So this is going to be a trial and error approach. Even professor says there is no like a systematic approach there. Like, it's going to be a trial and error. Many people can use different approaches to do that, in which every calculation takes a new nonce value. They do so because the probability of accurately guessing a valid nonce is close to 0. It's very like 0.00. So it's very very less. So for that reason, they try to keep it random. And the average number of hashing attempts is automatically adjusted by the protocol to ensure that each new block is generated on average. So every 10 minutes. So the consensus is also made in such a way, the values of threshold and other things are also set in a way that the average number of hashing attempts is automatically adjusted by the protocol to ensure that each new block is generated on average every 10 minutes, right? So that is the reason there is a set, because of this time, every block can be created every 10 minutes. There is a maximum number of time. Also, we are able to calculate that how many years it might take for us to exhaust all of the blocks, right? So this process is known as the difficulty adjustment, right? So this difficulty adjustment was made while making the protocol only. And this is what determines the mining threshold, right? So this process, which is helping us adjust how many attempts a person can make, is also letting us know the mining threshold. So how many zeros the block hash needs to start with to be considered valid. So instead of, professor explains, like, instead of thinking of how many zeros, consider it as the number of attempts made, right? So that is the nonce, right? So how many attempts that could be made is what you can understand. So the difficulty in mining a new block is related to the amount of hashing power, right? Committed to a blockchain system. So we'll discuss more of it as we proceed forward, but you can still understand that if miners decide to stop mining, the difficulty will be adjusted. Right? For example, the miners get discouraged, the difficulty could also be adjusted, and the threshold will drop, meaning it will be little easier to go ahead and mine, right? So it could be a value that will be also adjusted, but this is a hypothetical case, right? So more or less, this is all about the nonce. There's also a little of gray areas that might be there, more related to the proof of work or the difficulty. We're going to discuss that in our next session, like how nonce was not completely clear in our previous session. So similarly, we are also going to discuss that step by step. Okay. So I hope the concept of nonce was clear, and the understanding of how difficult the mining could be. If that is clear, we're all good. Apart from this, if there's any query, you can go ahead and put it on the chat. If everything is clear and understood, you can type U in the chat box. Thank you, Ravindra sir. Okay, great. Thank you, Sujam. So thank you, Raja sir. So basically, if people who have recently joined, if you have a challenge in understanding anything, you can always reach out, and you can start from the beginning, or you can go to the inner circle. In inner circle, even the recordings of the revision hackathons are also there. So one way is to go through the sequence from module 0 till module 10 without going through the recordings of the revision hackathons, or you can say complete module 3 in the actual lecture and then go for the revision hackathon also, right? So your concepts become strengthened. Thank you, Shirayo. Okay, so thank you so much, everyone. And we'll see more of this in our Tuesday's session for blockchain. Thank you, everyone.